Presenting whack-a-mole routing, the effects of ISP traffic engineering on non-ISP networks.
Hello, everyone. Good morning. I'm glad you guys could join me, and not too many of you are hungover, or at least not showing it. I'm hoping this, for a lot of you that work in ops or have been in ops before, this is going to be generally a review of things you've already had to deal with and seen. But for those of you who haven't, I wanted to go over just some of the things that we've run into at my current job over the years. So let's go to the first slide. So there are multiple issues that cause either traffic engineering policies to be implied or traffic shifts that basically impact CDNs or impact those that basically supply an application over the internet. Some of those TE policies are applied due to an issue, whether the issue is a link being congested and traffic needed to be shifted off it, whether it's an end customer of the ISP complaining about their current traffic path and wanting to shift over to a better one, or maybe it could just be a response to a deteriorated downlink. Really, the issue ones are temporary, hopefully, and are ones that I'll go into a little bit more, but it's a more common one that I've found when we're looking into issues on that. The second one is traffic engineering policies applied in response to a business requirement, and this is one that's a little bit trickier. We'll talk about it a little bit more. This essentially is where you start getting into the settlement-free interconnect agreements or the peering agreements, and you start talking about links being out of ratio, or you have companies fighting over those settlement-free interconnects, either by not shifting traffic off and leaving it congested, or shifting it off completely in order to get back into ratio and not be in violation and that sort of thing. Point 2 and 3, and 3 being the change in formal relationship. Basically, they're kind of linked because there are times where a company is small and they're a transit customer, but when they grow bigger or they're acquired and they go under their parent company, they transition from a transit customer into a peer, right, a settlement-free customer. And due to a lot of the default policy the ISPs do, that also has an impact, right? It becomes a de facto traffic engineering shift. We have the ever-present and the always going to be there misconfiguration problems, right? A policy that is misapplied or not applied at all ends up doing a route leak that draws traffic away from where it's supposed to go, or cuts off the route announcement, making that link not a great path that can be taken. The last point I added here, I wanted to add because it's a problem that we definitely ran into when we went from an AS per region to a single global AS. I know others have done that transition and may have run into similar problems. And that is when basically your route announcements are coming out of a specific region with a specific source AS. You can generally avoid mostly these problems, not all of them and not all the time. But when you go to a single global AS and you have all your announcements coming out every point, these problems become a little bit more prevalent and they hit you a little bit harder. So let's get into the first one. And I'm going to tell you now up front, I'm not great at drawing, so you're going to see this same drawing multiple times because I just kept reusing it. I would prefer a whiteboard that I could draw on and you guys could look at that and someone could come up and erase and we can have a good discussion. So this is the best one you're going to get out of me. I apologize. But essentially, what we have here is the issue response, right? The ideal path is ISP A to ISP C getting to the CDN, right? And by ideal, I mean either distance-wise where speed of light comes into play or congestion-wise where buffering comes into play. It is the least delayed path, right? It is the fastest path between the end customer and the CDN. Now, when the traffic shift occurs, right, either a TE policy or the link between ISP A and ISP C goes down, or whatever the case is, where the shift moves to the path through ISP B, we get to a scenario where it is what we would call inefficient as far as we're concerned, right? It's not that the packet doesn't get there. It's the fact that the route that packet is taking is detrimental to the metrics that we're trying to measure against for our service, right? This scenario, when it responds to an issue, also is when end customer A, as I say here, obviously on the slide, I want to read it to you, reports an issue, whether it's an attack, whether it's a issue with the link that they're noticing, and someone calls in and does a shift. In general, shifts done due to issues when we contact the ISPs and talk to them are generally temporary in nature, or at least we hope they're temporary in nature, and usually it shifts back. The second one that we want to talk about is change in business requirement, or a TE policy applied due to a business requirement. So this is where we start getting into that great subject that I know NANOG has discussed before, and all the papers have discussed before, right? Settlement-free interconnect fights between companies, between ISPs, because links have gone out of ratio. This is a particular fight that impacts us. We are the splash damage, right, of these fights between ISPs. They're having a fight due to their management or due to whatever the cause is. But even though we're not a party to that fight, the traffic shift that occurs or the traffic loss or the buffering that occurs by going over the congested link impacts us, right? It impacts our ability to deliver the application we need to, and it impacts our ability to serve customers. This is a more difficult problem to deal with. On later slides, I go into how you can approach and try to deal with this. Because as a third-party company, you don't, A, who wants to really inject themselves into a legal fight between two companies, and B, this gets beyond two engineering groups being able to talk and work out a problem, and now you're talking about more on the legal and the management side needing to work it out. So I wanted to point this out as something that occurs that is not necessarily temporary in nature. This could last months or years, or it can never be done, right? Finally, we have a change of formal relationship, and this is when a customer or a peer transitions to one or the other. As most of you know, in ISP land, but in my previous jobs, there are default traffic engineering policies depending on whether the link is settlement or settlement free, right? Most transit customers or maybe even paid peers have a local pref change that's done inbound on the ISP versus settlement-free peering, which is usually either left at local pref 100 default or at a lower local pref. This is just companies doing what is good for them. The good business practice of we need to make sure we send the bits over the links that are making us money versus the links that aren't making us money at all. But when you have an ideal routing path that is going over, in this example, ISP A and ISP C again, and keep in mind I did warn you, you're going to see this drawing over and over again. The path between ISP A and ISP B transitions to a transit connection, right? The ISP, let's say ISP B either fails to keep up ratios or fails to meet the requirements for peering on that ISP and is transitioned over to a paid peer or a paid transit. When that occurs, the default TE mechanism that most ISPs use, that being local pref, shifts that traffic over automatically. It's going to win. And it's not that there's any material change in the relationship as far as we're concerned or the end customer is concerned, but it's just a business relationship between the ISPs. This is a harder problem to address. A lot of the TE mechanisms that are available to a CDN to influence routing multiple hops away are no longer available to us when local pref is used as a default traffic engineering metric, right? So I'm going to get into possible solutions later on, but this is something that is a little bit more insidious and trying to address, and this really brings up the whack-a-mole portion of it, because as you, as a CDN, or even as an interim ISP, try to do policies to address it, you end up inadvertently breaking other paths, and then you have to go try to address those, and then other things break. So it goes into this never-ending loop that is not sustainable. And this is always the great one, right? This is just the classic misconfiguration, right? An engineer or operations or in deployment pulls up a new or establishes a new connection but fails to put in the in and outbound policies, or ISP didn't apply the inbound prefix list to ensure that their customer is not leaking their route table back to them, And for a brief period of time, we have poor end customer A pulling in traffic for the entire world. Misconfigurations, thankfully, are very brief in duration, but anytime something like this occurs, that creates essentially a de facto traffic engineering shift, this impacts CDNs and our ability to deliver the application. All right, so you've heard me say this a few times, and a lot of you are already familiar with this, but the question always comes up, well, why is one path better than the other, and why does it matter if your packets are still getting to the endpoint? It's not that we're talking about loss, or we're talking about complete isolation of a site. And for that, I basically, whoops, that's the back button. For that, I basically set up the same diagram, but now on a world map. So in an ideal scenario, we have a customer in Sydney that needs to get to the CDN. The closest CDN data center is in Tokyo. The ideal path takes them through the Asia-Pacific fiber lines to Tokyo. It's the quickest path as far as fiber miles and speed of light is concerned. It's the best path as far as congestion is concerned. That means the return is maybe, let's say, 150 milliseconds for return time, right? Now, when we talk about the inefficient path, where it has to go through ISP-B, we have a scenario where that same traffic now goes to the west coast of the United States, before then it finally crosses the ocean yet again to get into Tokyo. And that could increase the delay by over 200 milliseconds round trip. That doesn't seem like a whole lot of time to you and I. It doesn't seem like a whole lot of time taken in isolation. But when you consider that as far as my particular CDN is concerned, or others, when you have to establish TCP and when you have to do a TLS handshake, all of those round-trip communication times get that additional 200 milliseconds. Not to mention the amount of packets we have to send in order to load the UI and actually render the page. So it's not just a single 200 millisecond hit. It is a basically pile-on hit of every communication forward and back, right? Every two-way is a 200 millisecond hit. So what's the impact to that 200 millisecond? Well, for us, we have a thing most of you may be familiar with called Time To First Byte. That is basically describing when we have gotten the handshakes done for TCP, when we've gotten the handshakes done for TLS, and we're able to start handing the first byte actually related to the web page we're trying to load, right, for our application. For us, we have a metric we call end user page time, but it's all more commonly known as average page time, and that's how long it takes us to load the entire page. So between those two metrics, the increase in delay in the inefficient path would essentially increase the time until we get to the first byte of our actual data, right? This is just the handshakes that have to occur between us and the end customer. For the end user page time, that's how long it takes us to render the entire thing. The UI, the user pics, the actual customer data they're pulling up. And each of those, because of the mechanisms, the underlying protocols and mechanisms involved, also get the additional delay hit. All this, of course, leads to the third one, which is customer complaints. Customers do notice. And when they've been working all morning and they go to lunch and they come back and all of a sudden that page it seems like it's going twice as slow or 3 times as slow as it was when they came in, they're absolutely going to pick up the phone. And because we're a global company, like most CDNs, it's not like we have a good time for an outage or a TE shift to occur. If Europe isn't in the office working, then America is in the office working. And if they're not in the office working, Asia Pac is in the office working. So customer complaints are going to be there. Customer perception on how long it takes to load that page is often not, it's a perception issue. It's not the exact time that actually took the load. But to the customer, it's taking longer, and that's all they know, and so they call and complain. In our case, it's a little bit more difficult. End of month, end of quarter, end of fiscal are big deals for sales. So anytime during those periods where we have a page slowdown, even as little as a 200 millisecond shift in a path, that leads to a tremendous amount of complaints, and it has our ops groups and site reliability groups scrambling to figure out what happened. So let's talk about that a little bit. One of the difficulties we have is trying to divine the intentions of why what occurred, all right? Why did that shift occur? Why is it taking a different path? No, we don't think it's malicious. At least for the vast majority of the time, it's not malicious. But we don't know, right? We're on the endpoint. This is the internet. For a lot of our customers, they're crossing multiple ISPs to get to us. So we have to start looking at our monitoring tools to try to figure out where in the path did it shift, why did it shift. So the other difficulty is a lot of the times, at least for our company, and if I'm sure for several others, we don't have a formal relationship with the ISPs in the middle, right? They're not our upstream, they're not our end customers upstream. So with these difficulties in mind, you have to be careful about how you approach and how you basically contact them in order to try to resolve these issues. So this is NANOG. This is for ops generally. All of us have either at one time worked in operations or still currently work in operations. The first point is basically the biggest point I'd like to make. No one enjoys someone calling them up screaming, right? You've all had to deal with customers that called in stark raving mad, cursing up a storm, yelling about how you're costing them millions of dollars in revenue, et cetera, et cetera. You've all had to take the time to try to calm them down while trying to get information out of them so you can figure out what the problem is and resolve it, right? Keeping that in mind, basically, and going back to my previous slide, if you have no formal relationship and you call in a confrontational manner, that ISP engineering group, with ops or eng, whoever, has no compunction to work with you, right? And there's no repercussions for them not working with you. You're not a paying customer. Their management is not going to hold you accountable, or hold them accountable, rather. So you're basically asking for a favor and help, engineer to engineer, to resolve an issue. And the best way to do that is to approach it professionally. Talk engineer to engineer, and you'd be surprised at how many ISPs are willing to work with you and figure out the problem, even though you're not a paying customer, right? It's a key point. The second point I added here is an option. I added it here. I don't necessarily agree with it. Every time when I worked in ops, when I thought about a multi-party call to troubleshoot an issue, it made me shudder because it really is generally not a good idea. But sometimes you can get, if the ISP you're having a problem with is the upstream for your end customer, it is an option if the end customer is having that much of a problem, but doesn't have the technical expertise to actually talk to the ISP about what it is. However, this is going to be rare. The end customer sometimes will say, look, it's your problem, not mine. You need to fix it, to the CDN. Or we'll tell the ISP to contact, or just refuse to, just won't know how to do it, don't want to do it. It's really a courtesy if they really want to do it, and at the same time, you have to hope that ISP team really wants to work with you, right? For the reasons I even personally sometimes hesitate on getting on multi-company calls to try to troubleshoot something. Let's be honest, they're not always awesome. So I put it up there because it is an option. I don't really recommend that option unless you have no other approach that you can do. All right, so here are some solutions. These are kind of generic, but we're going to get into them. You can, as a CDN, you can do your own traffic engineering in order to mitigate the problem you just ran into. This, though, really turns into whack-a-mole routing. So you have one of the scenarios outlined before. You decide to go ahead and say, okay, for this provider, I'm going to prepend, and for that provider, I'm going to add this community that'll make sure it doesn't go out over there. Great, perfect, you just solved that problem. Unfortunately, what you also did is probably create 5 more problems because there's a bunch of ISPs in the world, and you just shifted traffic for a lot of them because by fixing that one, you actually shifted it for 4. So while it is an option, you will turn your ops team ragged, chasing down problem after problem. More importantly, I don't believe, I have it up here because it is an option, but honestly, long term, it's not sustainable. Hopefully your ops team somewhere has a documentation repository that they keep to talk about all the snowflake policies they had to apply in order to address problem A or problem B, and they can reference that for when the staff that you have dealing with this leaves, and the new guys 2 years later come in and they're wondering why those policies are there. Long-term sustainment, it hurts, it's not great. It also breaks standardization. The few times that we've had to do it, we've actually had to do it in a way where we had to standardize across our environment in order to keep standardization and to keep the load of snowflakes off our operations team. But it really is a last resort to try to address it, and I don't highly recommend it. The second is you can work with the ISP to try to undo what happened. For cases of outage or misconfiguration, that's probably already happening anyways, and the ISP was happy to work with you to let you know, maybe give you updates, as long as it doesn't, impact their ability to deal with the problem. But, I mean, working with the ISPs is still the ideal scenario. Try to come up with a fix that doesn't require you or they to deploy snowflake policies that are basically going to break their standardization, right? And finally, you can do this, we did it with a few ISPs, which is you can ask for or create BGP communities to do a certain TE function. The problem with this one as well is that it is trying to handle a single specific problem. And while ISP-specific communities can work within the ISP, as a CDN, it makes the middle ISP or even your upstream slightly less valuable as a transit, right? I want to be able to go everywhere in the world without needing to tell you, but don't send to him, because when you send to him, you screw up my traffic, and I can't have that. So it is, though, an option that's there. It is available. I know we have done it with a couple of ISPs, either with communities they already had that we just needed to be aware of, or ISPs that they created for us, or sorry, communities they have created for us in order to do a traffic engineering shift we needed to do. In the end, though, the ideal scenario is to try to revert what was done. That cannot always be done. When you talk about change of formal relationship where it's contractual based, while engineer to engineer, you can agree that maybe those TE policies don't need to be there. When it comes to management or it comes to the company itself, they're going to fight and say, no, absolutely not. We want paid customers to have priority over non-paid. When you talk about a settlement-free interconnect fight, either due to ratio problems or contractual problems or just plain legal problems, you may have to go to one of these solutions because that fight's not going to get done very quickly. And as a third party, I don't think anybody's company is going to want them to insert themselves into a legal battle between two other companies. There's no return on that, right? Basically, that is all I have for this. I originally wanted to do this as a panel, but based on it was a hit on me. I didn't get out the word in time in order to grab people up here to have them answer for other companies as well and discuss things. Does anyone have any questions about what I've covered?
Hi, Jay Gill from Infinera. I'm curious whether you think of taking out the middleman and trying to locate your points of presence closer to your customers and have fewer of those multiple ISP paths between you and the end customer.
Yes, although there's a scale problem with that, correct? And a deployment problem. So unlike an ISP, I can't deploy a couple routers in a known data center and bring up a POP and I'm right there. There's a lot more things involved with the CDN side of the house. And even if we did that deployment, just so that when you get to our company, you connect to our routers and we haul you back, you're talking about a lot of capital expenditure and getting into a side of the business that my company doesn't want to get into, right? We're not an ISP at heart. So that specific type of deployment, we're looking into it for certain areas especially, but yeah, that's the resistance I've gotten on that.
Thanks.
Matt Petak, Yahoo. So one interesting case that you didn't mention, which sometimes comes into play, is whenever there are disputes between other parties that may take a long time to resolve, where you are collateral damage, as you were saying, it can sometimes actually create interesting business opportunities where you can go to a fourth player in the marketplace, often a tier 2 or somebody that hadn't been considered interesting previously. And if they are in a party to have connectivity to the players in the dispute, you can often end up shifting your business arrangements around in a way that now leverages their dispute in your favor. So sometimes what can start off as an initial challenge for you can actually put you in a position where you can leverage new relationships to offset that by making a win situation for that new ISP. So sometimes you have to look at this with an interesting open mind for, it's a challenge now, it's a problem. What other players are there in the marketplace that now I can approach that may be also impacted by this, where we can gain a mutual benefit? So that's something for people to think about. Just because it's a problem now doesn't mean that there aren't other people affected who may now want to work with you because of it.
Right. Yeah, and absolutely. And as a CDN, you also want to keep looking around to see which ISPs have better policies, better reach. There should be a constant RFP process to make sure that you're getting the service you want. And yeah, if the two companies are constantly having a fight, yeah, it makes them a little bit less attractive. Yes.
Yes, Sven Wolf, Phonoscope Lightwave. I think you need to fix ISPC, or you need to get better connectivity to it. Because traffic engineering is, as you said, most of the time not malicious. It's needed for some technical reasons. And most of the time you can decide where you send your traffic, but how your traffic comes back to you, you have little control over that.
That's kind of the point I was trying to make. Traffic engineering absolutely sometimes is done for a reason. The reason impacts us, though. We have tried different ways of addressing it, and I'm trying, please don't take it as I'm accusing the ISP of doing something to try to personally screw me or my company or anything like that. That's not what I'm getting at. It's just more making aware from a CDN perspective, these little shifts, which are just day-to-day business for an ISP, but what impact they have on us. And some of it is how quick we're trying to deliver our service. If it was something that we did not want or did not care quite as much in delivering as quick, right, for the entire page render, then it'll be a little bit more leeway, we'd be a little bit more relaxed about it. But I don't want to give the impression this is a confrontational thing between us and ISPs. It absolutely is not that. A lot of the guys that I work with come from ISPs, so we understand what's going on, and that's why we call to try to find out. And if it was a real reason, right, they're dealing with an issue, or they're dealing with a relationship change, or they're dealing with, even they put it in because they're out of ratio and they had to shift it over. We just want to get the end reason, and then we need to work with them on what we can do for our stuff, kind of a deal, right?
Yeah, just think about the poor customer that is only connected to ISPC and has no other path to you. So I think your solution will be, as previous said, probably to expand more and get closer to your end customers.
Right.
Hi, it's Andy Davidson from LonApp. I enjoyed the presentation, thank you. One of the, I think, takeaway messages that I agree with is that ISPs do really care, and if you approach them and say, we have a mutual customer who, and this needs to be fixed, that's something they want to hear. But if those ISPs can't buy different ways of reaching your service from their from their facility, wherever they're doing their aggregation, then what can they do about it? So my question would be, is your peering DB record up to date, and are you planning to build some more places? Because if you're trying to improve connectivity to ISPs, that's a really, really good way of doing that, just doing more public peering.
Right. Our PNDB records are up to date, yes. I helped maintain them, and I handed off to another engineer who's now maintaining them. We cleaned them up a little over a year and a half ago and got them back under control. We are unfortunately not at a lot of IXs right now, but that is because of the choices of where our data centers are deployed. But we do explore and look at them. We just, like every other company, we have to show an ROI even for an IX connection, because they're all going to be either a metro or long haul connection. But yes, we try to work with ISPs. We've announced a few partnerships to that effect to try to get connections into larger ISPs that are essentially settlement free in order to try to expand our reach. But yeah, the one thing we not can't afford, but don't want to pay for is buying a transit with everybody in the hopes that we don't have to run into this problem, right?
Yeah, I think you're right. And your ISP custom or your end users, it's the new BlackBerry. The product's like crack; they love it. So it's a latency-sensitive application that people really care about. And if you have a look at the direction of travel for other people that run latency-sensitive services, I think you'll find that direction of travel is towards more and more peering with the access ISPs. So it might be something to consider.